Okay, today I have a little mini lesson for you as a review of some of the topics we talked about at the end of the unit on factoring. We're going to talk a little bit about the parts of a quadratic equation, quadratic function, a little bit of review, and then a little bit of new material to help you do your homework worksheet tonight. So we'll start. I'm going to step out of the way so you can see. We have a function, a quadratic function. You can see f of x equals x squared minus 4x plus 3. And as a review of our terminology, we talked about this function being a function because if we look at the graph, this would pass the vertical line test. Anywhere we drew a vertical line, it would intersect this graph in only one place. So every x value corresponds to a unique y value. And quadratic meaning of the degree 2. So if we look at this function, f of x equals x squared minus 4x plus 3, the first thing we need to review is how we find the degree of a polynomial. Degree of a polynomial is defined to be the highest degree of any of the individual terms. So if we look at f of x equals x squared minus 4x plus 3, we have three unlike terms. The first one being x squared, the second one being a minus 4x or plus a negative 4x, and then finally the constant and addition of 3. Talk about degree of a monomial being the sum of the powers of the exponents. So if we look at the term x squared in this function, we have a variable of x to the power of 2, so we would consider this a second degree term. Negative 4x would have a degree of 1, x to the first power. And our constant 3 could be written as 3x to the 0 power, recalling that any number to the 0 power has a numeric value of 1. So this constant, and all constants, have a degree of 0. Now, degree of a polynomial then is defined to be the degree of a polynomial is equal to the degree of the highest overall term. So this has a degree of 2, degree of 1, degree of 0. Remember, I like to refer that as the hostess with the mostest. So we're going to say that this polynomial has a degree of 2. And of the second degree then makes the word quadratic. So quadratic is when we're talking about any function that is of a degree equal to 2. All right, we're going to work on identifying parts of this function, of this quadratic function. And the first thing that we're asked to identify, and you will be on your homework assignment as well, is what is the quadratic term of f of x equals x squared minus 4x plus 3. Quadratic meaning of the second degree. So which one of these terms has a degree equal to 2? And as you can see from when we labeled the degrees of each of the terms individually, the one that has a degree of 2 is x squared. So our quadratic term is referred to as x squared. Linear term. If you remember from Algebra 1, we did a lot of study of linear equations. In slope-intercept form, a linear equation looks like y equals mx plus b. So if we made a more concrete example, we'd have something like y equals 3x plus 4. Writing it as a function, we could change that to f of x equals 3x plus 4. Consider the degree. The degree of 3x is 1. The degree of 4, once again, is 0. And the term with the greatest overall degree is this, 3x. And the degree is 1. That's what makes this be a linear equation. The highest overall degree is 1. And when we graph it, if you'll recall, we get a line that has a y-intercept at b and a slope of m. So linear term, this implies what is the term that has a degree of 1. And in this case, we have a negative 4x that has a degree of 1. So when we list the linear term, we're going to include the sign in front of it. And because it's negative, we're going to call that negative 4x. Constant term, then, is the term that we say has a degree of 0, or the constant in your equation. Remember, constant is something that never has a value that changes. 3 is always equal in value to 3, so therefore the constant term, including its sign, would be a positive 3, and we can just write that as 3. Okay, so now if we consider the graph, we're going to talk a little bit more about the anatomy.
Whoa, 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 DuVal, what are you doing, man? Not man, woman. If my students are going to watch this, they need to see me in part of this. I'm their teacher, right?
Yeah, that's right, Mr. Cundy.
Okay, hand it over.
All right, here you go.
She wants to hide off the screen. I'll be a real teacher up here and actually stand in front, okay? So that was all good, DuVal, okay? But now let's get to the real stuff with graphs, okay? So if we actually take this function and put it on a graph, the shape, which we worked on, is a parabola, obviously. And there are certain aspects of that parabola that we want to make sure we understand and can identify. The first one being the vertex. Okay? Vertex is either the minimum of the parabola or the maximum of the parabola. Okay? And the vertex in this case, you can see, is right here at the ordered pair 2, 0. Okay? That's all you need to put here for the vertex. Now remember another thing, and that jumps down here to axis of symmetry. The vertex is defined as the point being on the axis of symmetry. Remember that axis of symmetry? Maybe I'll grab a different color here. That axis of symmetry is the vertical line that divides your parabola exactly in half. In other words, if you took half the parabola and folded it over that axis of symmetry, it would line up exactly on top of each other. So if we maybe even jump down to number 3, that axis of symmetry, remember a vertical line always has the equation x equals some number. Okay, and in this case it goes through x equals 2. So x equals 2 is your axis of symmetry.
Mr. Cundy, let's go back and check our vertex again. We have it labeled as 2, 0, and if we look at that graph, 2, 0 doesn't seem to be a point on that parabola.
I think I'm all that, and I missed the most basic thing ever. DuVal, I'm sure glad you're here. This whole time you're going, what is Cundy doing? Let's back up a second. Now all my students can laugh at me and
it's okay.
Say Miss DuVal is the real Algebra 2 teacher. Gosh, where is that point? 2, -1. I guess I was just getting all excited being up in front of the camera.
That looks good now.
Woo! Okay. Is this vertex a maximum or a minimum? Well, it's the lowest point, so this one is a minimum. Not too much else to say on that one. We already talked about the axis of symmetry. And finally, your roots or zeros. You guys got pretty good at this not last chapter, the chapter before, when we were doing factoring. The roots or zeros occur where your parabola crosses your x-axis. Okay? And in this case, there are 2 points there. It crosses here at the ordered pair 1, 0, and at the ordered pair 3, 0. Okay? So when we write that, DuVal, I can't remember, did you say you let them write it as ordered pairs, or did you always want them to write it as x equals 1 and x equals 3?
I prefer the ordered pair notation because I think easily it's confused with number 3, the equation of the axis of symmetry, if we write our roots and zeros.
Yep.
I think either one is correct by convention, but I'd like to differentiate between axis of symmetry. We're going to use the equation x equals, and when we list our roots or zeros, we'd really like to list those right now as ordered pairs, remembering that the x-coordinate is first and the y-coordinate is second.
Yep. All right, thanks. Well, that's your introduction to this next unit, Unit 5, where we're doing quadratic functions. Do your best on the homework.